This meeting is being recorded. Please be on mute until you are ready to speak. And barring any technical difficulties, the recording will be posted to the KDOT YouTube channel shortly after the meeting. So we have a fairly robust meeting today, some great information, and we do have a big discussion topic at the end, or an announcement topic, and we want to make sure that everyone stays tuned for that. Without further ado, Pedro Lopez and Nash, if Nash is available, from Ainstein. You guys take it over. I'll stop sharing. Feel free to share whatever you want to start.
Awesome. Thank you so much. We're just excited to be here. Nash is about to join in just a couple seconds, but I'll get it.
I'm in here as well, real quick.
Oh, there we go.
Yep.
Perfect.
Hi, nice to meet you guys.
Hello.
So then I'll move ahead to start sharing our presentation. Let me pull it up. There we go. And resend. There we go. Excellent. So once again, thank you for having us. We're excited to start joining these new sessions. And we're excited to also present a little bit about ourselves. Ainstein, we like our slogan. It's a genius in radar. Today, we're here presenting mainly on our aerospace side, but I'll give a brief introduction on the company. So we started in 2015, located here in Lawrence, Kansas. Our CEO was involved very much with the University of Kansas. He fell in love with the town, with Kansas by itself, and now here we are. Very exciting. Since our founding, we've been able to work with a lot of different projects and companies. So, for example, we have partnered with Texas Instruments for the design of the antenna for the IWR-6843. We've also partnered with Deuce and Bobcat for our Series A, and then we've done some joint development. We've been able to create certain radar sensors specifically for them, so that's been a very fantastic project. We've also partnered with Full Swing Golf, which is another company that is involved with TGL for golf projects. Tiger Woods was also a part of this. It was very, very exciting. We created, we can actually see it very small here, the launch monitor, so it's capable of keeping track of the ball's speed, angle, range, all of that. So it was a very fun project. We've also worked with Case New Holland for some of their agricultural projects. And then we also like to point out that we have some worldwide presence. We have distributors all around the world. That includes Turkey, for example, where we are partnered with Leo Drive. And then, yeah, Ainstein just keeps expanding. At the moment, we have our main office here in Lawrence, Kansas, and we also have a second smaller branch in Lenexa. So it's been all very exciting. Here's very briefly a little bit about our portfolio. So as mentioned, I'm going to focus most of the presentation on the aerospace altimeters, but I just wanted to mention that we're also in the autonomous driving market through our different vehicle sensors, including the 079, which was the project we worked a lot with Deuce and Bobcat. Then we also have some products in the Internet of Things, and then sports radars. For example, for sports radars, very recently we partnered with Athlon, another local Kansas company. They do scopes for just hobby shooting, and then we've been able to develop a new Rangecraft product for them, just to be able to keep track of the speed of bullets, and then just for hobby and be able to improve on your shooting. But yeah, apart from being in those markets, we have had a lot of focus on the aerospace ones. Actually, when Ainstein started, our main focus was solely aerospace, but then our CEO realized that radar technology can help in many other use cases. But moving towards the altimeters, at the moment, here in this presentation, we have 3, and then Nash is going to be able to present our last one. But for these initial 3, we have the USD1, which is our flagship product. It was presented first into the market during 2017, and since then we've been able to produce and sell out around 25,000 units. So it's been very, very great. Then we have the LRD1, which is a long-range radar altimeter, and then its Pro version. But I'll jump into some more details specifically for each of them. So I was mentioning the USD1 flagship product. It is our smallest one at the moment. It has a range from 0.5 up to 50 meters. And then, yeah, it's compatible with PX4, autopilot. Most of our commercial autopilots, they have already tested the USD1, and it's been integrated into multiple projects. Here's a quick spread of worldwide where we have seen the deployment of the USD1. So the US, obviously, we have seen it a lot in European projects. We have seen it in Africa, South America, and the Asia, and then Australia. So it keeps expanding, and we want to continue showcasing it and making its presence more and more worldwide. Some of the main applications we have seen, the USD1 specifically, but radar altimeters be occupied on has been smart agriculture, drone delivery, flights over water, takeoff and landing. Very quickly, a reason for these great advantages and the application in these specific use cases has been because the radar altimetry technology works in a way very different to, for example, LiDAR. For LiDAR or laser altimeters, how they employ laser in order to get that range from the drone to the ground in this case, just like us. But the complications with laser is that light works in the nanometer scale, its wavelength, and then by working these such a small scale, it has the large chances of interacting with smaller particles, such as the spraying out of a smart ag drone, that can be dust out of the environment, different small particles that can be present in the air. That's one that's been the main reasons, for example, why Case, New Holland, Doosan, Bobcat, these companies have decided to also invest into radar technology. They see a lot of its safety advantages and how it can serve in specific markets. So that's why radar altimetry has been very useful, specifically to those applications I showed in previous slide. And then, as I mentioned, flight over water, radar can use water surfaces as well as the ground for reflective surfaces, compared to, for example, laser altimeters that they would sink a little bit slightly into a water surface and then get you a little bit of spotty, erroneous readings. Moving on into our next versions of radar altimeters, we have the LRD1. This was our second model. This one has a bigger range. It has a range from 1.7 up to 500 meters, which, as you can see, it's way larger. This one was mainly created for more rugged applications. It's been tested in flights of up to 200 meters per second. It's been shock tested, vibe tested. So as you can see, it has a more kind of rugged tactical application. Some of its main scenarios in which we have seen it has been in heavy UAS that can be cargo vehicles, for example. We have seen it applied in sea skimming for larger systems, and then tactical, as I mentioned. Another additional one has been in geophysical surveying. How our radar altimeters have helped a lot is, for example, in companies that still use helicopters even, they would add an LRD1 sensor, and they would be collecting their geophysical data through their instruments, and then they correlate that with a specific altitude above ground level that we provide through the LRD1. So that's been another way in which we have seen our technology help in one of the different markets in the aerospace field. Here's a quick example. We can see the GPS data, how it was collected. So here it would be before being adjusted with respect to sea level, and here is after adjustment. And here we can see two LRD1s being just tested at the same time. Here's another example flight, and for this one, we get to see more of those slight changes. These showcases how the LRD1 is actually using data that is available right below your drone, compared to, for example, GPS, in which you get a good idea of what's your altitude, but you don't really know what's in your environment, and environments change. And now that we're working towards a market and a UAV pointing history in which we'll see so many drones flying around with the new Part 108 and beyond visual line of sight flights becoming more of a thing. So once again, from Ainstein, we have been focusing a lot in trying to provide, in a sort of way, ears and eyes to drones. Here's on its way back for landing. So once again, we can see how we can see a variation in the terrain. We can see that there's a bigger decrease, and then there was a slide up. So you might have seen maybe a tree, maybe a building. So you can keep track of what's that actual distance between your drone and what's below, which is very helpful and keeps your system safe. And finally, we created a pro version of the LRD1, the LRD1 Pro. Some cool thing about it is that it uses 24 gigahertz and 60 gigahertz at the same time simultaneously. These to provide a precision of 1.5 centimeters for low altitudes and 7.5 centimeters for high altitude ranges. So basically, what it does is that it employs 60 gigahertz for altitudes between 0.3 up to 5 meters, and then it uses the 24 gigahertz for ranges from 5 meters up to 500 meters. So we can be way more precise. And then another huge advantage of the Pro version is that it is available in a lot of different communication protocols. We have seen that products can vary; they may have different requirements. So CAN, RS-232, 422, 485, and URTTL. Very similar to its predecessor, the LRD1 Pro has seen its main applications with tactical, rugged markets and systems. It's industrial grade, it's high fidelity, it's been high speed, high shock, and high vibration tested. Once again, the dual radar configuration is very innovative. There's not a lot of dual radar altimeters in the market, and commercially available even less. So that makes us very, very innovative. And then the centimeter level precision is very helpful. Some of the use cases in which we have seen it applied has been aerial targets, for example, employed in a lot of different countries. It helps them just test out their different defensive systems by just employing a very similar aerial target system. Here's an example, just like with the LRD1 of the LRD1 Pro. This was a flight of up to 80-ish meters, and we can see how in blue, the radar altimeter was able to provide all these different changes in the terrain compared to barometer in green, and then GPS in red, which would just be providing you above sea level altitude, which once again, for hindsight, it's very helpful in your general flights, but if you really want to keep your system safe, you also need something that is detecting above ground level. And finally, here's a quick table of the specs of the first three we have presented, but now Nash also has a quick data sheet on our newest product. So I'll stop sharing, but I can share this presentation as well with the whole community once we're done with the meeting today. But yeah, I'll move on to Nash.
Awesome. Thank you, Pedro. I'm Nash. I'm our aerospace testing solutions engineer. Pedro was able to give everyone a good look at our initial 3 radar altimeters. But what we're really excited about is we actually have a new radar altimeter that has already been released, and our first shipments are expected to begin September 8th. Something we're very excited about is the USD1 Pro. So it is actually kind of similar to the LRD1 Pro. It's just the Pro version of the USD1. It's just an upgraded version. It has a higher altitude range. It's also a lot more water resistant. It's as you can compare to the LRD1, LRD1 Pro, and USD1, they are all IP67. But as you can see here, the USD1 Pro is IP69K. So that's one thing we're really excited about. Another thing that we're really excited about is that the USD1 Pro is actually designed to DO-160, DO-178, and DO-254 standards. So for any sort of manned aircraft applications, that's something that's very eye-catching. And then additionally, like I said, it's built for a higher altitude range. So as you can see here, the altitude range of the USD1 Pro actually upgrades the USD1 from 0.5 to 50 meters all the way up to 120 meters, still operating at the same frequency of 24 gigahertz. So it should come with all of the same certifications and same standards as the USD1, just a higher altitude range. And on top of that, not too much heavier than the USD1. The USD1 has a weight of 110 grams, but the USD1 Pro is actually only 140 grams. So it's only 30 grams heavier. So not too much heavier than the USD1 to account for that 70-meter extra altitude range. That's something that we're very confident in and proud of. And then additionally, the dimensioning of the USD1 Pro is also quite similar to the USD1. It's a little bit smaller in length, but a little bit thicker. So when you kind of compare the two, it's pretty similar. And then finally, currently the USD1 Pro will become available with both private CAN and drone CAN. So for any private CAN users, it will be compatible with that, along with the drone CAN, which is a lot more of a public interface, which allows for a lot easier access into any flight controllers. Kind of like Pedro had mentioned, what we're really proud about with our radar altimeters is that they're super seamless and they don't require calibration. So it's really cool about, especially with the USD1 and USD1 Pro, they're such commercially available products that you can just plug it into your flight controller. For example, it's compatible with ArduPilot or PX4. You can just plug it in, quickly switch your parameters to allow for rangefinder readings with the radar altimeter. We currently already have a driver in both ArduPilot and PX4 that allows for Ainstein specific products to be implemented into their flight controller. So you can easily just connect it to your flight controller, change the parameters to the radar altimeter you want, and then from there it should be good to go. That's a big plus with radar altimetry when you compare it to other altimeters such as GPS or baro. For example, barometric altitude is based off pressure and it requires calibration kind of based on location and where you are. As compared to our radar altimeters, no matter where you are, it just gives you the AGL altitude. And like I said, seamless, very quick. And yeah, so that's our USD1 Pro. And that's kind of the final point we wanted to get to. Like I said, they are currently out and our first batch of units are set to start shipment on September 8th. If there's any questions, feel free to ask.
Thank you, Pedro and Nash. Appreciate that. Any questions for either one of these gentlemen? Quick question for you. Are you guys, so everything you're looking at essentially is, and forgive my ignorance in the field, everything you have is currently basically on board technology. Are you looking for, are you at all looking at, ground-based technology in the future? Or is that not a direction you're heading?
That is an excellent question. So we do have sensors for ground level vehicles. So those would be more in the 77 to 79 gigahertz frequencies. Those we have them available, but they're slightly different to, for example, our radar altimeters. So radar altimeters are ready to be purchased directly on our website. They're commercially available off the shelf, like Nash mentioned. For vehicle radars, we can work it out. We have them ready, but they have to be implemented into larger projects.
Gotcha. And are you looking for any further research and development, any, collaborative opportunities? Can we help make connections that can enable your, operations within the state of Kansas?
Absolutely. Yeah. So we were so focused in just trying to make us, worldwide known that we also missed the moment in which we had to just become Kansas known at the same time. So we just want to just get to know everyone, all the players that are available here in the state of Kansas. So I think this is a perfect opportunity for us to start doing that. Our technology, some of it's already tested, like the USD1 since 2017, but we're getting new products like the USD1 Pro that Nash just shared. And then we're working into newer technology. I think I can share very briefly into it because we're still in the very early stages. But for example, we're working on an air-to-air detection radar for UAVs, which will be very nice once again for now that BVLOS will be a huge thing. We truly think, as I mentioned at some point during the presentation, we're trying to provide the ears and eyes to the drone. And then as we keep developing more technology, then yes, we'll be very happy to just find these collaborative opportunities in which any of the people available here or outside of the organization in Kansas can help us just testing and provide feedback on our sensors. That would be very good.
Please keep us posted. That obviously that is something that's very compelling and would be meaningful, not only for the state of Kansas, but obviously nationally, but more worried about the state of Kansas first. I may be partial. Any other questions for Pedro or Nash from Ainstein? Thank you very much, gentlemen. Next up, Thales.
Thank you.
Chris, jump on in.
All right, thanks, Ray. Let me start to share the screen here. So let me know when you can see that.
You're coming in really soft, Chris. So I'm not sure if everyone else is picking up on that or not, but
can you hear me?
Perfect, beautiful. Thank you, sir.
And normally people don't have a hard time hearing me. So, all right, am I sharing my screen?
Yes, you are.
All right, great. Okay, so thanks for inviting us to participate. I'm pleased to be able to give everyone a little bit of an overview of Thales. So Thales, let me start with the first slide here. Okay, so Thales is a global aerospace and defense company that you may or may not have heard about. We have a significant presence in Overland Park, Kansas, that I'll get into in a few minutes. But first and foremost, just to give you a little bit of background on Thales Group. So it's a portfolio of solutions and products that span the gamut of multiple markets in the traditional aerospace and defense world. So we have solutions in satellites, radars, sensors, missiles, avionics, and of course air traffic management, which we'll talk about in more detail. We're also a significant company with a lot of with a significant focus on investment. So we consider ourselves a high-tech company. We're a major player in things such as cybersecurity, identity protection, and banking. In fact, if you have a credit card in your wallet, there's a very good chance that there's Thales technology embedded in that card and on your person at this very moment. And a little bit about what we do here in the U.S. In terms of our presence and scope. We have a nexus in 22 different states, and we do about 3.3 billion in revenue each year in the United States. And as I mentioned, we have a presence in Overland Park. So that's what we're going to talk about next. So here in Kansas, we're really mostly known about our leadership in aviation. The company dates itself back to 1932, the founding of Wilcox Electric. And Wilcox Electric was one of the very first companies to sell systems and solutions to what was then known as the Federal Civil Aeronautics Administration, the precursor of today's FAA. And we've been providing the FAA and the USDOD with systems and navigation and surveillance systems for over 80 plus years. And a lot of that work comes out of our Overland Park office and facility. So we've been supplying those, just to give you an example, a couple of those systems. So for example, if you have ever landed at an airport in bad weather with poor visibility, it was a Thales instrument landing system that has guided you safely to the ground. And that is a system that we designed and built here in Kansas. More recently, we have embarked on a number of large programs for the USDOD and also the FAA, and we're proud to say that we're supplying the FAA's latest MODES radar program and looking forward to some of the opportunities that will emerge as a result of this brand new air traffic control system. So, with respect to air traffic management more broadly, Thales is the global leader in air traffic management solutions. Some interesting facts and figures on this slide for you to look at, but we supply radars, navigation solutions, and automation systems to not only the FAA and the USDOD, but to ANSPs all over the world. And one of the most significant statistics that I can tell you is that over 40% of the world's airspace is what they call flight information regions, is managed by Thales's Top Sky automation system. So we're very proud of that. And in terms of Top Sky, I'll give you a little bit more background on that and how it translates into what we're doing more broadly with respect to emerging aviation. So the Thales Top Sky automation platform is a proven aviation grade solution, and it's a comprehensive solution for airspace management. Thales has a product-centric approach to most of our products. And with respect to Top Sky, it's a cloud-native, cyber-secure, flexible, and scalable architecture, and it's all built on a legacy of mission-critical software that was designed first and foremost for aviation safety. One of the things that's interesting, and I think this is as it pertains to some of the interesting the opportunities that are emerging as a result of the tragic events in Washington, D.C. in January, is that the Secretary of Transportation is looking for a brand new air traffic control system. And one of the key components of that they're looking for is something called a common automation platform. And the Thales Top Sky product actually is extremely well suited to that. So we support all phases of flight, tower, terminal, en route, and oceanic from a common system. And I guess more importantly, as it pertains to what we want to talk about here with this group, that same capability is also part and parcel of our ability to seamlessly integrate new entrants into the national airspace. So all of those aspects are are key elements of what we do. And we'll talk a little bit more broadly now about the early or emerging entrance aspects here. So as you may, if you're not aware, Thales is was selected in 2020 by the state of North Dakota to supply a new capability to integrate emerging entrants into the airspace. So this project is called Vantis, and it's fundamentally all about integrating new entrants and unmanned systems into the national airspace system. It's also about establishing beyond visual line of sight operations, which is one of the crucial capabilities that's required to unlock the economics of unmanned systems. So the approach that we took to working together with our partner at the state of North Dakota and our customer was to leverage our aviation grade capabilities and bring those many of the building blocks of that top sky system that I just talked about, integrate those with ground-based sensors to enable what we now have, which is thousands of square miles of airspace in North Dakota that's open for beyond visual line of sight operations. So on this next slide, I won't talk to it in too much detail, but this gives you a little bit of a brief overview of some of the milestones. So I said in 2019, the state kind of kicked it off. Thales was selected as the systems integrator. We've worked together with the state to build out a number of different service volumes, and we've gone through a lot of work developing the processes and procedures along with the FAA to make sure that the ability to get beyond visual line of sight approvals is faster and more expeditious, and it's really now culminating with the release of Part 108 and the notice of public rulemaking that's out there now and open for public comment. And I'll talk a little bit about that next, but certainly one of the key things that we were able to do here is to work with the state and the FAA to get the NTAP process up and running, which rapidly accelerated the ability for operators to get approval to fly beyond visual line of sight. And as I noted, we now have today, we support today thousands of square miles of airspace in the state of North Dakota, and also now more recently in the state of Michigan. We've also don't have that on this timeline here, but we've been selected by the state of Michigan to provide effectively an extension of this capability into Michigan, and now opening up corridors for BVLOS operations in Michigan, most recently for their unmanned triple challenge. And then what I wanted to touch on last was this. Okay, so just kind of a brief overview itself of the Vantis service. So again, built on the Thales Top Sky aviation grade capabilities, integrating a variety of different sensors on the ground to provide detection of non-cooperative traffic as well as cooperative traffic with ADS-B radios, and further attempting now or working with the state of North Dakota to integrate radar data from national assets such as FAA and DoD sources. And ultimately, we are optimistic that capability will be made available more broadly to really open up the not just what we have in North Dakota, but everywhere else where we can integrate, ingest FAA radar data and provide BVLOS services based upon this capability. Okay, and then finally, I don't know how many of you have had a chance to look at the Part 108 rulemaking, but we were really super excited with what we saw there. Obviously, it's a difficult read, and I'll be the first one to tell you that I'm not the expert in terms of digesting that, but fortunately, I do work with a number of experts. And one of the things that we found most intriguing about it is it's pretty clear that the FAA was watching closely what's going on in North Dakota. Obviously, they were watching it closely because they've been a partner in that process all along. But many of the key elements that were built into the Vantis system, a lot of the rigor and a lot of the processes, so because it's not just about technology. Technology obviously is a cornerstone of what you do, but it's really about your safety management systems and your quality management systems and all of those processes that are required. That certainly operators of airlines and air carriers are all familiar with in terms of their operations. They are key to what we're seeing in Part 108. And the framework for that was really integral to what we did in terms of building out Vantas. And then what we're seeing here with Part 146 is the ability for what they call automated data service providers to get a certification. And again, we're thrilled to see that many of the capabilities that were built into the solution that we provided for the state of North Dakota, that is Vantas, is really effectively what we're seeing under Part 146. So we believe that the solution that we have, which is extensible to other states, as we've demonstrated with Michigan, and we're certainly very keen to bring this capability and technology to Kansas. But we're really kind of bullish on the fact that we believe we're well positioned to get certification under this Part 146 and enable operations for many different service providers and everywhere that we provide surveillance and BVLOS coverage. And I think with that, I've reached the end of the presentation.
Thank you, Chris. Any questions for Chris? You guys can jump right in, or you can also jump in at the end of the next presentation as well, should you have any questions. Any questions before we move on? Thank you, Chris. Next up, Vigilant Aerosystems, Zach or Crady? Sorry if I mispronounced that.
Hey, Ray.
Hello,
It's
hello.
Crately.
Thank you.
Yeah,
Jump
absolutely.
right
No
in.
problem.
Thank you for joining us.
Good to see you here. I'll do a quick presentation here. How long did you want us to present?
We have until 4 booked out for this discussion, so 15 minutes would be great, and then we have some discussion points or discussion topics at the end.
Absolutely, that sounds perfect. So I'm going to present a little bit of information about our Flight Horizon Tempo product, and also have more general overview information. But this is specifically about the product that uses ground-based infrastructure, radars, and other sensors to provide all the infrastructure that's needed to enable beyond visual line of sight flight, to enable airspace management. We also have an onboard system that we are developing for the Air Force and for other advanced air mobility applications, but this is really focused on our ground-based systems. So I'm Crately Epperson. I'm the CEO and co-founder, and we have offices in Oklahoma City and in Grand Forks, North Dakota. We work closely, as you'll see, with NASA in California and with several other research and development centers in Fairbanks, Alaska, at Virginia Tech and elsewhere. So our focus is on multi-sensor detect and avoid airspace management software for UAS and AAM. We've been working on this based on a couple of NASA patents that we licensed and published multiple papers with NASA for about 10 years now. Flight Horizon Tempo is our hosted managed airspace management system. And so we bring it in as a full software as a service. We also have hosted it for the Air Force behind their firewall on their private servers, but it is a managed hosted system that integrates with networks of radars, networks of ADS-B receivers, ground control stations of multiple UAS or AAM aircraft, remote ID receivers, and then FAA and weather data. So we pull all that together, and I'll show you some screenshots. We've done work and have contracts with NASA, the FAA, various state and federal UAS programs, UAS and AAM manufacturers. So people who are developing the aircraft and operating them. And we've recently done that SBIR Phase 2 with the Air Force for our onboard system. The point of this is to enable safe beyond visual line of sight. And we focus on having mobile technology. Even the large radars are all designed to be part of a mobile networked system with either terrestrial, cellular, or satellite communications to allow them to be deployed as needed. So we do track ownership. So this is what's called an ownership-centric DA and aerospace management system. This gives you big advantages in terms of being prepared for the future of autonomy, gives you big advantages when you are working on flying beyond visual line of sight with UAS, because it actually is able to comply with the technical standards, utilize something called ACAS-X, which is a collision avoidance algorithm from the FAA, and that is implemented in all of our software. We are plug and play with multiple models of radar and ADS-B receivers, and that greatly reduces the amount of effort required and the amount of risk in getting a system like this up and running, and can be a real cost saver. Because we've already invested the time and money to have that integration with multiple receivers and multiple ground control stations. So basic product features, and then I'll get into a little more detail here, is to detect, track, warn, and avoid. So at a baseline, our system is really focused on safety. It's focused on providing that automatic DA function, whether you're using a large-scale system across many square kilometers, or a small-scale system like the one in the picture here that might be mobile or portable. This is NASA using it over the Gulf Coast area in order to track supersonic flights. So we provide the software for NASA to do that. And then on a small scale, we can do it with small aircraft and small drones with portable systems. It's really designed to be safety as a service, where we can manage the system for you, provide it as a bundled package with a basically a rough set annual cost that gives you what you need to operate the system without a lot of unknowns. So we have 4 products. I'm going to talk about Tempo. Pilot is the onboard version, which I won't talk about in this presentation. The basic system layout would be to have the Flight Horizon Tempo system running in the cloud or even on a private server to pull in data from autopilots. So we usually connect to the ground control station, or we can connect to a UTM system. We have a UTM version of this that can pull in information from a variety of data sources as part of the UTM process, pull in information from the radar to track non-cooperative aircraft that might come into the airspace. This is very important to be compliant, that you can track non-cooperative aircraft without transponders. And then we have transponder receivers, and we usually have a remote ID receiver as well. All of that comes in, it gets deduplicated, correlated, and then it is displayed in the system. And then it has those automatic DAA warnings, which I'll show you in a video here. So this is another NASA Airspace Manager using the system, in this case in Florida. This is what the user ID looks like. This is just a few of the features, but you'll see here, this is the actual system running. On the right-hand side, you've got the white aircraft with that well clear, that yellow ring around it is the safety distance that it is required to maintain from other aircraft. On the left-hand side, you've got a detected aircraft that has a predicted trajectory that's going to go through that well clear. And so you have a warning, loss of well clear predicted. And so the software is constantly monitoring this, usually multiple times a second, but at least once a second, depending on what sensors are attached. And then it will do this calculation and provide this, this instruction, this command to turn left, descend, slow down in order to maintain that well clear. And that can actually be sent to the autopilot in addition to being sent to this screen. So this is a system that is really future-proofed for a very high degree of autonomy. And it uses those what are called ACAS-X algorithms so that it is out of the box compliant with the FAA's required collision avoidance algorithms and standards, DO365, ASTM F3442. I serve on the committees that help to write those. I served on the FAA's Aviation Rulemaking Committee for Beyond Visual Line of Sight. And so this is all inherent to the way that we do ownership-centric safety. So the, let's see, I'm going the wrong way here. Here's another one. So real quick video of this. This is the system working here. This is actually over University of Alaska Fairbanks. You'll see that on the left-hand side, there's an aircraft that's approaching the ownership, in this case, a drone, predicted loss of well clear, so it's provided that warning. So you take that warning, you turn left, and you prevent that loss of well clear, fly over to the left, speed up a little bit, and then you can maintain that safe distance, which is really critical. And then you can get back on your flight path, well clear of that other aircraft. So some use cases that we're seeing, and I'm going to talk about some specific uses: air parks, drone ports, state and federal programs. We're being called in by all of these types of programs to implement our system, get it in place, get the infrastructure, get it into place, and get it all integrated. It provides improved safety and flight authorization, in addition to attracting operators, which is really critical, particularly for drone ports. And we do a lot of the engineering support to make this happen, but a lot of the functions come out of the box with this system, and it's all managed and hosted. We're seeing great interest in supporting some DFR programs. So you all have probably heard about DFR. This is a program where the FAA is accelerating approvals for different types of first responder drones, particularly for incident response. We support mobile assets, so you can go set a system up where you need it and then be able to quickly respond with technology that you're already familiar with and have trained on. And then, of course, the future of this, we're really excited about Part 146 and its support for Part 108 and the proposals that were made there. I was on the committee in 22 that released the report that made a lot of those recommendations. And so the ability to provide that automated data service supplier service is just integral to what we do and the way that our system works right now for multiple users. So this is a system, and this is the one that I think Ray may have heard a little bit about when he was visiting Oklahoma recently. This is our Flight Horizon Tempo system at the Oklahoma Air and Spaceport. This is out in western Oklahoma in Burns Flat. We've got about 5,000 square kilometers of coverage. We're going to have about 10,000 square kilometers of non-cooperative air traffic surveillance coverage towards the end of this year, early next year. The system is out in the field working now. You can see it working there on the bottom left. That's the actual coverages of some of those radars. We're in adjustment and testing of those radars. But this is a really exciting system. This is an active testing facility and military flying facility, but it is owned by the state of Oklahoma. Burns Flat is operated as a spaceport and as an airport. And so this is going to spread out throughout western Oklahoma. Another one that we have is in Tulsa. This is the system at the Skyway Range. It started out as a system for Skyway 36. It is operated in support of the Osage Nation-owned Skyway Range system. That's been there for more than a year now, and this is another one of these radars. It is mobile, but it's there most of the time, and they do all kinds of flight testing with it, and it has good surveillance over Tulsa, and in fact, there are more radars and systems being added to that. There's another system that we have just started setting up. We haven't really done public announcements about it yet. USD Aerospace has. This is at Gorman Field. This is in support of some recent military flight testing, and is with a couple of radars that are manufactured by DTEC. A lot of these larger radars are DTEC radars. One is fixed and one is portable. And so that's exciting. We're going to see much more use out of that over the next year, but we've done our first major program with that, and they've done a press release about that. It's another system that we did for the 49th Operating Group. This is in New Mexico, and this is for the training flights on the MQ-9 Reaper. So this was using a variety of data sources, was running entirely privately on the Air Force cloud. These are public flights. They're broadcasting ADS-B, but we also injected FAA data and other data into the system so they could get additional safety and additional coverage. So these are all screenshots from that system. Here's a small portable system that we set up for NOAA for some flight testing, just tracking drones. So we can track small near-term targets or larger, longer range targets. Another system that we set up for the AFRL research that we've done. This one is in advance of our onboard system, again with small radars instead of the large radars, but they work very well on the ground as well. So this is some research we've done. This was at Oklahoma State University. We won NASA's 2021 Commercial Innovation of the Year Award. So we were really happy about that. We've had great support out of NASA, and they use our software actively. Little bit of information about these radars. I won't go too much into that to leave time for questions. But this is the 7360. It's an advanced 3D digital radar. We are the first user of this for airspace management in the US. Our radar that you saw earlier at Skyway Range is the second of those radars manufactured, and it's the first one used for airspace management. We now have lots of them in use, but we were essentially the earliest user of this, have a very close relationship with DTEC. And then their older, slightly better known radar, the S200 Harrier. This is a 2D radar, and we also have numerous of these that we use. And they provide 2D but much longer range coverage for traditional airspace surveillance. We do a lot of studies when we set these up. We do the work to be sure that they are going to be able to track what they have to track in order to get the right types of authorizations. And that's a very typical part of what we do. So that's built in. We have a lot of other projects. I won't go into all of these. They are gone over a few of them, but we've also had some recent very strong military interest, which is great for the commercial market because it allows us to develop advanced capabilities. And because these products are dual use, we can bring those back to the commercial market. A little bit about the software. It is modern software. It's built on a modern stack. It is designed to be hosted in the cloud. It is designed to be highly extensible. We do add new sensors. So we add new radars as they become available, as we've just demonstrated with this new 3D radar. And we really specialize in rapid integration of new technologies and new capabilities. We're really excited about that and excited about the growing opportunities with Part 108, Part 146, and also just growth in the AAM industry. We have a variety of contract vehicles. I can talk to you about how that works. And that's my presentation.
Thank you for that. I do have a question, but I'll leave the floor open for anyone else. Any questions for Crady? No questions at all?
So I went pretty fast. Sorry.
Yeah, no, that's and great presentation, great information. I appreciate all three presentations for sure. Question: you mentioned DFR, you mentioned portable or mobile equipment. You definitely showed a lot of that in different form factors, from a tripod to a trailer back to a vehicle. What kind of turnaround time from we need to move to this location, being able to get on location, get everything set up, and have everything up and running? What kind of time frame are we really looking at?
Yeah, with the small portables. So that when I say portable, I'm mostly talking about the ones that'll fit in a backpack. You did see those on a tripod, and we do take those out in a matter of an hour or two. We can usually have those set up. If we're doing experimentation, it's 3 or 4 hours because we've got to set up a lot of equipment. But generally, it's a couple of hours. And that's mostly because we do have to do some calibration. We have to do some clutter mapping. There are things that we do to be sure that we're observing the right things. But that takes, not very long. The larger ones, which we call mobile because they're on a trailer, but tend to be situated in one place for longer periods of time. Those are designed, and our operating process is designed to get those in place and set up in less than a day. It can take up to a day, and oftentimes that really depends on networking availability and capacity. It depends on the ability to do the initial clutter mapping and be sure that the radar is seeing what you expect it to see. But those are highly mobile, and we have regular trucks with trailer hitches that we can attach those to and move those around as needed. And then once they're in place, there's a little bit of work to be done, but that's usually in a day. Depending on what you're doing, it might be a couple of days, but not much longer than that.
Any other questions from the group?
Ray, it looks like we have one in the chat.
Oh, okay, I missed that. Thank you. All right, Ethan, is there any limitations on height for these radar drone detection ranges? These could be great to detect UAS hazards around the airports, but I wonder the altitude envelope.
Yeah, so the larger radars go up to, they go up to about 18,000 feet. We get good coverage above. I mean, they continue to have great coverage above 10. There comes a point where you need to tune them. If you're looking for higher altitude aircraft, you can actually tune them to do that, and that will decrease some of the lower altitude coverage. And so you can trade off depending on what you're trying to do. If you are looking for drones specifically, you can use the 7360 for that, certainly, and you want to tune it for that. But typically you're looking for drones that are going to be at kind of a lower to medium altitude, right? So you'll tune it for that because you're worried about safety in your terminal operating area typically. And so you'll tune it to cover that area. And then for the small, the Echo Guard, for example, is the model of the small one made by Echodyne. Those are the portable radars. Those have a few thousand feet of altitude. And they've got essentially a couple of kilometers of non-cooperative aircraft, so like a Cessna, and then they've got just under a kilometer for drones and small drones, roughly. They're rated for that. We have good experience with them seeing at that range, but those are relatively shorter ranges just because of the physics of those antennas and the way that those are used. But we also have a product called Flight Horizon Defender, which uses those smaller radars on a portable or mobile basis, and it includes remote ID. So you can say, I see a drone, I have a remote ID signal from that drone, I can tell which drone it is, who owns it, how it's being operated here, or it distinguishes, and you can set up a geofence where you say, if anything comes into this area or comes close to this area, I want to know about it. I want to be alerted. And it'll do that for both remote ID, it'll do that for ADS-B, it'll do that for the radar target. And then if it sees a drone that does not have remote ID, meaning it's not compliant, it's some kind of rogue drone, it will throw an alarm on that. And the screen will show you a red box and say, here's a drone that doesn't have remote ID, or here's a drone that does have remote ID, but it's coming into the area that I do not want drones today. And it'll throw an alarm. So that's what our Flight Horizon Defender product does.
Thank you for that. Before we jump to our major announcement, any other questions? And the minimum detection altitude is below the 400-foot max drone altitude because it is so. This sounds like a huge safety boon. All right, thank you, Ethan. All right, if there are no other questions, I really appreciate the presentations. I do want to share a major announcement. You guys have heard this. You've received 56 million emails on it, but we will have an event to commemorate the completion of the Kansas Emerging or the Advanced Air Mobility Roadmap release in Wichita, Kansas. The event is going to be September the 18th from 3 to 5:30 p.m. 3 to 3:30 will be sign in, get refreshments, get yourself situated. The program will start at 3:30 and it'll be in Wichita State at the NCAT campus at the Jabara Airport. You will receive an email with an RSVP. It will be RSVP only. However, we want basically industry, anyone that can help us with phase 2, which is implementation. So the goal is to show the AAM roadmap, market analysis, and economic impact study and release that to the public. That's a process that many on this very call have been active and participated in and provided input. And then after showing the roadmap, show how to navigate the roadmap. It's separated into various work streams by different roles. So, government can go in to see what needs to be enabled within the state. The airports and infrastructure and academia can see how to enable those various roles within the state, or at least the recommendations, looking at short, medium, and long-term recommendations for the state. It is intended to be a living product, so it is not the be-all, end-all. However, there's a ton of great recommendations in there, and I'm sure it will be updated as we move along and as we have progress. Phase 2 is the essentially working together for implementation. It's extremely important. This is a big waste of time and energy if it just sits on our computer and we do nothing with it. What a wasted, what wasted resources. So please join us September the 18th. You'll receive the email with an RSVP. Respond to that. Forward the RSVP to people within your organization that you believe would get value from seeing this information and would want to be part of this. We're also looking for relevant displays. So if you have any relevant items you want to display, if you're a vendor or an OEM and want to display items, please reach out to me. We'd love to have this be a meaningful display of the technology, because we're going to have a ton of stakeholders there that can help with phase 2. We need to get people excited about seeing all of this in action, and I think some great displays would be amazing. So if you would join us, look for that RSVP. The September Emerging Aviation Technology Working Group meeting will be that September 18th meeting. We will not have a meeting at the end of the month. However, the next regular virtual meeting will be in October. Any questions before we conclude the meeting? Any comments, concerns, questions? All right, hearing none, I appreciate everyone's time. Look for this recording shortly after the meeting. It'll be posted to the KDOT YouTube channel, KDOT Aviation YouTube channel specifically. And really appreciate your time. Thank you for joining us.
Thank you, Ray.
Thank you, guys.
Thank you.
Thank you.